Hello, today I'm going to answer question number 3 that says inside a thermometer there is usually 9 millimeters of Hg. How many molecules of Hg are present? First, we need to see what are the units we have. We have volume, that is 9 milliliters. We have density, that is 13.5 grams per milliliter. And we have the molar mass of Hg, that is 200 molecules. We need to find molecules. But first, to find molecules, we have to have moles. And to have moles, we need to have the mass. And the mass, we get it by having density and volume. Here we have the units. Then we exchange to get mass. And it gives us 121.5 grams. Then with this we exchange it for the moles and we get mass divided by the molar mass, that is 200. Then we got 0.6075 moles. Then we multiply it by 6.022 times 10 to the power of 23, and it gives us this answer in molecules. Here are the operations, and here are the formulas we use for this problem.
Hello, I'm Andrea Julica Putores and I'm going to explain problem 8. So it says, liquid NH3 reacts with O2 gas to produce NO gas and liquid water. In an experiment, 32.5 grams of NH3 are allowed to react with 35 grams of O2. Determine the limiting reactant. So we have this equation that is now balanced, and then we see what the problem gives us. So it says that for the mass of NH3, we have 32.5 grams. And for the mass of O2, we have 35 grams. So we see what elements do we have. We have NH3 and we have O2. So we see our periodic table to see the molar mass, and in NH3 we have 17 grams per mole, and in O2 the molar mass, obviously we see in the periodic table the oxygen has 16 grams per mole, but now that we have O2, we multiply 16 times 2, and the total of molar mass is 32 grams per mole. And now that we got the equation that is balanced, we have to get the proportions. From proportion 1, we have 2 moles of NO. We have 2 moles of NH3. We have, yes, we have the 2 moles of NO for proportion 2. And we have 2.5 moles of O2. So now that we have this, you see that this is in grams, and we have to get to the moles. So we use this formula to get 2 moles. So we have 32.5 grams that we divided with 17 grams per mole, and we have the moles, that this is the answer for the moles of O2. And for the moles of NH3, we do the same. We gather the 35 grams and divide it by 32 grams. No, I'm incorrect. Sorry. This is the O2, so this is the O2. And this is the NH3, sorry. And we divided and we got the answer of 1.09375 with a calculator of moles. And now that we got this in moles, we gotta cancel them out with proportions. Like we have this number right here of NH3, and we see that in NH3 we got 2 moles. So we put this down to cancel it out, and because we have to get NO, we put NO, 2 moles of NO here, up, and then we cancel this out, and we multiply this quantity with 2, and we divide it by 2, and we got the answer of 1.9117 moles of NO. And to gather the other result, we have the 1.09375 moles of O2, and we cancel with the proportion of 2.5 mole of O2, and up we put again 2 mole of NO. So we cancel this out, we multiply this by this, and we divide the result with this quantity, and we receive the result of 0.875 moles of NO. But this is by O2, and this result is 1.9117 mole by NH3. Now we have the second part of this problem that says, if the conditions are STP, how many liters of nitrogen monoxide are produced in experiment? Tip: you can only run a reaction until the limiting reactant runs out. So we have that is STP. So for P in O2, we have that is 1 atm. For a T in O2, we have that it's 0 centigrades. And if we have R, we obligately have 0.0821, and we have this that it has to be always atm, atmospheres, liters, kelvins, and moles. So we gotta change this 2 kelvins, but it's 0, so we have automatically 273 kelvins. And we have this formula for all that we have, because we have to get to the volume of how many liters of nitrogen monoxide are produced in the experiment. So we have this formula: pressure per volume is equal to nRT. And because we gotta have volume, we simplify and get P down, because we have to get to volume. So the formula is this. So in the other problem, for the moles of nitrogen monoxide, we get that is 0.875. So we substitute 0.875 times R, 0.0821 of R. For temperature, we have 273 of temperature, because it's Kelvin, dividing it by pressure, that it's 1 of atmosphere. So the result of all this problem for the volume is 19.61 liters, and that is the final answer of this problem.
Okay, here I am analyzing the 12th problem. I will read it. Cows are known for their methane production. There is estimated that a cow is able to produce over 300 liters of CH4, which is methane, per day. And then we know that a car generates daily 13 kilograms of CO2. Then we must know, we must compare both contamination produced by the car and the cow, and which one retains more heat, and justify by procedure. Okay, I would like to explain first that I always like to write my data: 3 liters of CH4, a pressure of 1 atm, temperature of 26 centigrades or 299 Kelvin degrees. We have the L variable, which stands from atm multiplying L dividing by Kelvin per mole. 13 kilograms of CO2, which is 13,000 grams of CO2. And also I wrote here that 100 moles of CO2 trap the same as 1 mole of CH4. Then I have my formulas. P times B equals to N times R times T, and molar mass equals to mass divided by N, which is the number of moles. I will start with methane. I would like to start calculating this as an extra, but in the problem it is not needed, because we have all that we need, which is moles. So then we substitute the variables. We know that P equals to 1, volume equals to 300. Remember that in volume we work with liters, with temperature kelvins, and mass with grams. Always have that in mind. We have the variable R and T. Then we have 1 multiplying 300, the R variable multiplying 299, that gives us a total of around 12 moles of CH4. Okay, we have that quantity of moles. Then for CO2 we calculate molar mass, since we have mass, and we can calculate mass of, molar mass of CO2. It is 44. We then we make this procedure. We solve for n, which is number of moles. Then we have 13,000 dividing 44. That gives us 285 moles. Then, if 1 mole of CH4 does the same as 100 moles of CO2, then we proceed to multiply the number of moles of CH4 times 100. That gives us 1222 units of heat. Then, as it should be, this should be the answer. The 1222 units of heat with the cow, and 295.45 units of heat produced by the car. And that's it.